Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Chemistry Paper 1 Higher Tier from 2025. Question number 6 is on the topic of quantitative chemistry. Some reactions appear to involve a change in mass. A student investigated the change in mass when solids were heated. Figure 7 shows the apparatus. So you have a crucible with the solid heated, and there's a tripod as well. So the student determined the mass of the contents of the crucible at regular intervals. The student used a Bunsen burner instead of a water bath to heat the crucible. Suggest one reason why. Well, a Bunsen burner has to be capital. Bunsen burner reaches a higher temperature. Now you could say the water bath will not be hot enough. The student planned to heat 0.01 mole of magnesium, 0.01 mole of magnesium carbonate. So the equations for the reaction is, so in this first one, it's an oxidation reaction. Oxygen is being added to the magnesium. Here is a reduction reaction, since oxygen is being removed from the magnesium carbonate. So the first one will gain mass, the second one will lose mass. Figure 8 shows the students' predicted results. So here you have magnesium carbonate. It's reducing mass from about 8.4 to about 4. Magnesium is gaining mass from 2.4 to 4. Look at figure 8. Explain two trends for the first 3 minutes. So in the first 3 minutes, so right up to this point. What's actually happening? Magnesium carbonate is losing mass. So first of all, magnesium mass increases from 0.24 and 2.4. 0.24 to 0.38. Here it's reducing to 0.44. Okay. So to 0.38. Because they're asking you to explain, you need to give a reason why. Since magnesium gains oxygen when it's forming magnesium oxide. Magnesium carbonate decreases in mass from 0.84 to 0.44. Since magnesium carbonate or we could actually say, since carbon dioxide is released. Figure 8 shows that both reactions are complete after 5 minutes. Why is the final mass of the contents of the crucible the same for both reactions? Now, If you look at here, they're saying 0.01 mole in both. That means they're using the same number of moles. Now, if you look at the mole ratio, it's all 1:1:1. So they will both produce 0.01 mole of magnesium oxide and in each. So the mass has to be the same. Both reactions produces 0.01 mole of magnesium oxide. The student heated magnesium carbonate. Figure 9 shows the results. So the predicted results line is higher than the actual results, but they both wind up at 0.4 grams. So the decrease in mass is actually faster in the actual results. The student concluded the difference between the predicted results and the actual results is caused by solid escaping from the crucible. If the solid escaped, then the mass should actually change, final mass. But it doesn't. Give one reason why the results show that the student is not correct. If solid escaped, the final mass would be lower for the actual results. Than for the predicted results. Iron reacts with steam to produce an oxide of iron and hydrogen gas. 0.12 moles of iron reacts with 0.160 moles of steam. Determine the balanced equation for the reaction. You should determine the simplest whole number ratio of iron to water. The formula of the iron oxide produced. So you have to do 3 things here. Let's find the reacting mole number ratios. For that, you will need now. So iron is to steam. Oops. Is 0.12, that's for iron, divided by 0. Write it the other way around. Is to 0.16. Divide both by 0.12. I will get 1 is to 1.33. If I multiply both of them by 3, I will get 4 is to 3 is to 4. 3 is to 4. So the ratio is 3 is to 4. The formula is going to be Fe3 H2O 4. No. Yeah, that should be. No, that's a mistake there because I'm writing it as moles of steam formula of iron oxide. It's not. We get rid of this. Formula for iron oxide, O4. The balanced equation for the reaction, FeH2O, Fe2O4, and hydrogen H2. So that's 4 oxygen. So let me use a different color. That's 4 oxygen on both sides now. That makes it 8 hydrogen. So I would need 4 there. And I made a mistake there, Fe3. So that should be a 3 in front of it. That brings us to the end of this question, and I will see you in question number 7.